Hey guys, welcome back to another week of robotics. So today we are going to be introducing coding. But before we do that, I need to introduce one more thing that we're going to find inside our kit here. So earlier, or last week, we learned about the momentary button. If you remember, the momentary button is something where you press it, and as long as you hold it down, whatever you're trying to do will last for that moment, and when you let go, it will pop back up and the moment ends. The other thing, the new thing that we're going to add today is called a switch. So I'm going to go ahead and explain that. So let's take a look at the whiteboard here. All right. Switch, okay. So inside your kit, you're going to find the switch, and the switch is this thing here. Let me update our, okay. It's going to look like this, and it's called a sliding switch actually because you have this top part, it switches back and forth. And we talked about that it's the type of thing that's used to control your classroom lights usually, and because when you flip it on, it stays on, right? It wouldn't make sense to have to hold your classroom lights on for the whole class, right? That would be a waste of time for someone to have to do that the whole time. So you want to use a switch where you flip it on and it stays there, and then when you want to turn it off, you flip it off and it stays off. Okay? So there's different times to use a momentary button, and then there are other times to use something like a switch. All right, so it's got 3 pins here on the switch. So I'm going to put it here, and let's talk about how this thing works. Okay, so the switch looks like this. All right, and it's got 3 pins. Now, here's how we want to think about it. Let's call these pins A, B, and C. Okay? Now, the top part right here, depending where it is, it decides which of these pins are connected. All right? And let me draw this so it's going to be a little bit more clear. So I'm going to delete that. All right, so if it's like this, what's going to happen, and you might be able to tell here already, if it's like this, A is connected to B. So what's going on is that underneath, on the bottom of this black thing here, the sliding switch, the sliding part of the switch, is a metal, and what it does is creates a path between A and B. Okay? And when that happens, look, C is not connected to anyone. All right? And now let's change it up. What happens if we slide it to here? Well, it's going to be the opposite, right? You're going to have B is connected to C, and then look at A. A is all by himself. So that's how we use the switch, or that's how the switch works. And so now the next step is to figure out, okay, so I know how the switch works. How can I now take that, take what I've learned to create a light switch? So basically something on our breadboard, a circuit, where when I turn it on, it stays on. When I turn it off, it stays off. So let's see how we're going to do that. All right, we're going to move over a little bit here. All right, so let's draw our schematic here. Oh, let's change back to this color here. We're going to have our Uno. Okay, we're going to have our 5V, and we're going to go to a resistor, to an LED. Okay, let's do our pluses and minus. And we do have a G and D connection, as always. And this is how we're going to do the switch. So I like to just draw in our switch. with its 3 legs. So if I connect the minus of the LED to here, and then I connect the GND to here, let's see what happens. Okay, so let me change this so that it's more clear. So let's check it out. If I switch it like this, what's going to happen? Use this. Well, we have electricity can flow through all the way through. I have a closed circuit, so we're good, right? Now, if let's make sure it works, right? If I put it here, what happens? Well, electricity will try to flow, but it will get stuck right here because look, there's no path for here. So if electricity can't get all the way through, we have an open circuit and the light will be off. Okay? So let's go ahead and try to build this circuit right here and make sure it works. All right. So let's grab our stuff here. All right. So let's first thing let's do the 5V. I always like to start from the power. Okay. So 5V. I'm going to use red here. So find my 5V right here, and let's use my power rail. I like to use my power rail. Boom. Okay. Now the next thing that I want to do is get my resistor. Let's use 470 ohm resistor. All right. So 470. There we go. All right. And then the other side of the resistor, we go into any hole at this point. I'll just go right there. Okay. And then my LED is this one. Okay. And what I want to do is do the plus leg on the resistor, on the new resistor row, and the minus leg a brand new row because we're going to make that connection later. Okay. I'm going to move this like this so that you can kind of see all the connections here. Cool. And then now we get our switch, and we look at our switch. The important thing here is to notice the middle row. Okay. So the middle row, if we look at our schematic, will be connected to G and D. Just want to make sure I point that out for you guys. Right? The middle row right here is connected to G and D, and then the side rows, we have the side. Actually, I shouldn't call it a row. The middle pin. The middle pin is connected to G and D, and then the side pins. One of them is connected to nothing, and then the other one is connected to the minus of the LED. So let's do this. So I'm going to do this. The middle row will be connected to nothing for now, but we're going to connect it to G and D later. And then one of the side rows is connected to the minus of the light, which is right there. Okay. Now we got that. So at this point, one of the side pins is connected to the minus of the light, and then now the middle pin has nothing on it, but we're going to connect it to a G and D. Let's see, this pin here is broken, so I'm going to get rid of this. Here we go. Okay. So the middle to G and D. So I got that one, and then this side just goes to G and D, right? And we should be good. So let's make sure it works. Okay, it's on right now. Now if I flip my switch, off. On and off. On. Cool. Okay, so now that we have that working, I got a couple challenges for you guys. I won't go into it all right now, and hopefully you guys can get it. We've done something like it for the past 2 weeks. So what I would like you to do is take this circuit that we just built with a switch and go ahead and add 2 lights, or actually add 1 light so it becomes a 2-light circuit, and then also do 3 lights. All right. So same circuit as this, where it turns on and off like that, and you know it's slides on, stays on, slides off, stays off. But I want it with 2 lights, and then I also want it with 3 lights. All right. So that's the first set of challenges. The next thing that I want to talk about now is that coding part, right? So like, how does that come in? So let me go back to my whiteboard here. All right, make some more room. Okay. So the next part is we need to figure out how do we get our computer or our Arduino Uno to be able to turn the switch on and off. So that's the thing about robotics, is that it's not humans controlling the robot, right? There's actually there's a computer that turns the robot a certain way to go a certain direction, or to turn on the lights, or whatever it may be that the robot is trying to do. It's not humans controlling it. If it was humans controlling it, it would be some kind of a mechanical device, right? So if you think of like old toys, like I don't know if you know what a jack-in-the-box is. It's just mechanical, where a human has to like wind it up and then it goes. But that's not really a robot. A robot would be like a jack-in-the-box that would wind itself up and work by itself, right? So how do we transition from, and I'll write this out, how do we transition from a mechanical, I'll call it a mechanical switch, all right, which is, you know, the switch we just learned about. How do we transition to that to a computer switch? It's like, what is that? What's that about? Well, I'm going to draw something here. Okay. What is this? This thing is a transistor. Okay. What I want you to know today is that a transistor is like a computer switch. So this sliding switch right here is a mechanical switch that humans need to turn off and on. A transistor is a computer switch. It's something that switches, but you don't have to do it with your hands. The computer can do it. Okay? And so let's talk more about this transistor. Okay? So inside our Uno, going back here, okay, inside this Uno, there are a bunch of transistors, which are basically the computer switch, right? Like I said. Now, we want to think about, all right, how many are there? Well, that's a good question. Here, let me turn this right side up here. Move this out of the way. All right, if you look closely at the Uno, check it out. You see 0, 1, 2, 3, 4, all the way up to 13, right? 0 to 13, those pins all represent these computer switches or transistors. Okay? So we have, if we wanted to connect a light to all of these, how many would we have? We would have 14, actually. Because look, it goes up to 13, okay, but it starts at 0. So 0, 1, 2, 3, 4, all the way up to 13 is actually 14 different lights that we could control. All right, because of each of these have a transistor or a computer switch in them. All right, so what we're going to do is we're going to create a circuit and connect to one of the 14 computer switches. All right, so let's go back to our drawing here, and I'll tell you more about these 14 transistors. Okay, so we have our Uno. All right, and we know that there are from 0 all the way up to 13, right? All those transistors. Now each one of these transistors looks like that symbol. Okay, and this is how it looks. All right, so what's coming out of the pin is going to be this part right here. All right, now what's going on is this part right here is connected to, I'm going to draw G, N, D. All right, so you got one part of the transistors coming out like that. And just to clarify, like, what do I mean by coming out like that? What I mean by that is that when I say it's coming out, it means that when that it's coming out to this pin, these ports right here, or pins right here. Okay, so that's the part of the transistor that you're going to be connecting to. And I'll keep this here as so if you look up at the whiteboard here, all right, so the part coming out right here, okay, is going to be the part that you're going to be sticking your pin into, okay, over here. Now, going back to the whiteboard, inside there's one part's connected to G and D, and then what's up with this internal part? This internal part is actually like one way to think about it, okay? I'm going to write the word. It's like a nerve. Okay? So inside your body, there are these nerves, and so what happens is that our brain will send a signal to our nerve to tell it what to do. Okay? So the same thing is like in this computer, because we said the computer or the Uno is the brain of our robot, right? So the brain also has nerves. And so what happens is that the brain is going to be sending something along the nerve, which is like this part of the transistor, okay? And that controls the transistor. Now what is going on is that when the nerve turns, I'll write it right here, the nerve can either turn on or it can turn off. Okay, so check this out. When it turns on, okay, when the nerve turns on, what's going to happen is that this part is connected all the way like that. Okay, that's when the nerve turns on. But when the nerve turns off, what happens? Well, you're going to have this connection still, right? But this is no longer connected to here, to the G and D. So it's like if it turns off, that means that this part right here, electricity will try to go here, and then it's just stuck. So you can't make a circuit. All right? So on means you get a G and D connection. Off, you're stuck. All right, so that's just a little bit of intro about how a transistor works and how it's related to the Uno, which is the brain of our robot. So now that we kind of know a little bit more, let's create a circuit, or more precisely, a schematic for a light that is connected to a transistor. Alright, let's see if we can do this, guys. Okay, I'm going to try to do a better job this time. Let's go here. Okay. We have our Uno. Okay. And we have a transistor. And that's connected to G and D. So one part's connected to G and D, right? This part is the nerve. And looking at it, I'm going to go to pin number 7. Okay, we just like to use number 7. And then this is also, this is going to be this, I'll call it the 7 nerve. Okay, and that's part of the brain. Okay, remember the nerve is what controls if the transistor is on or off. And then what we're going to do is connect, we have 5V. You know what? Forgot about that. 5V, I forgot about our resistor. Our LED. And then if we think about it, where do we always connect the minus of the light? We connect it to what? We want it to connect to G and D always, right? So check it out. If my nerve turns on, if you remember what we talked about, if it turns on, what's going to happen? I'm going to have 5E through there, through there, through there, all the way through G and D. My light is going to be on. Nice, right? Okay. But if I turn it off, what's going to happen? Well, these are all connected, so it's going to try to go here, electricity here, here. But when I do that, remember, this part gets blocked. This is no longer connected to G and D, so it just gets stuck there. So if my nerve turns off, there's no light. All right? Okay, so let's make the connection, and then I'm going to show you guys how this is going to work actually on the computer. All right, moving here. Here we go. Let's get our Uno, and let's use our 5V here. All right, so I'm going to say, where are we at here? Okay, got 5V sticking into there. Let's take my stuff out here. 5V into the power rail. Cool. And then let's do our resistor. Let's use 470 ohm. Take it in like that. Okay. Let's get our light. The plus leg of the light goes into my new row here. Minus row of the light goes onto there. Okay, my minus pin is down here on row number 8. And then let's not use black because now we're connecting it to actually a transistor here. So let's use green. Okay, so let's go to the minus row, which is row 8 for me, and go to pin number 7. Pin number 7 over here. Boom. All right. So now I'm going to plug it in. All right, and this light should not turn on because we have to write some code first. So, okay, it did not turn on. That's good. All right. So, the next step. Let us do some code. Okay. So what we're going to do is first we have to open up Google Chrome. Okay, and what we're going to do is go to code.barnabasrobotics.com. Okay. Now there might be a few options here. All right, you're gonna might see some stuff here. Let's make sure we click. If you see something like this, click on text code, and then it should look like this. Okay. If your screen looks like this already, don't worry about doing that. All right. The next thing that we want to do is select board. We want to make sure we select Uno. Okay, because we have a Uno board here. All right. Now it's time to start coding. All right. So. Here is what we're going to do. We are going to, you just follow what I do, okay? Void, and let me see if I can zoom in here, guys. I don't want it to be too small, right? Void setup, parentheses, curly brace, okay? And then void loop, parentheses, curly brace again. All right, so these, I just set up here two functions, okay? A function is basically a set of instructions within code. And so let me back up a little bit. So right now, what we're going to be doing through this code.barnabas is we're going to be writing computer code, which is the commands for our Uno right here, all right? And so what we're going to do is write the code, and then later we're going to send it through this blue cable right here to here, and then that's going to turn the light on and off. All right. So now let's look at the code. We have two functions, which are basically a list of instructions. We have setup, and we have loop. I want to point out a few things. All right. You can't do like this, all right? You see how I have a capital S instead of a lowercase, all right? Everything is case sensitive, so that means that you have to write it exactly like how I have it, okay? You can't do like an E here. You can't have like a space there. That's all gonna mess up the code, all right? So that's something to keep in mind. So as we get started, we just want to make sure that you do it exactly like how I have it. Otherwise, we're going to get messed up. All right, so let's see, void setup. So what we're going to do setup is we're going to put this pin mode 7, comma output. All right, so what's going on here? So inside our setup function, what we're saying is that we want to look at pin number 7. Why? Because we connected our green wire to pin number 7. So we need to set it up, and we need to tell the Uno that we want to make it an output. All right. You could also make it an input, but that's not what we want. We want an output. A light is going to be an output because we're sending light signals out, because the light is going out into the world. Okay, that's the way we want to think about it. So we want to set up pin mode 7, pin 7 as an output, and then the command to do that is called pin mode. And I want to point out, you see it's like lowercase p right here and a capital M right here. That's all very important. If you did it like this, it's going to mess up. How do I do now? There's something we can do to check to make sure everything's cool. You see here, let me make sure you guys can see this, okay? You see here it says compile. You can press compile there and check it out. You see it says error pin. It says error pin mode was not declared in this scope. What does that mean? That just means it doesn't understand this. So I need to change to capital M, and you press compile. So compile is like a check. Make sure everything's cool. There we go. So now no errors. Okay. Another thing I want to bring your attention to with the pin mode is that you see the sorry, not the pin mode, but with the setup is that there's these two curly braces. You got one here and then one right here. Okay, so that's important because these two curly braces this one here, this one here. That is what contains all your list of instructions, right? So you put all this stuff in here, all right? So what this means is that all this stuff will be inside my list of instructions for setup, okay? If I took this and put it out here, right, this one right here is not inside the curly brace, so it's not going to be part of my instructions for setup. Okay, there we go. So pin mode is set up. Pin number 7 is set up. Cool. Now that we've done that, we want to move over to the loop function. Now, the loop function is also a function, but here's the difference, okay? Setup, and I'm going to do something called a comment. I do 2 slashes right here. Setup runs only once at the beginning, okay? So what that means is, like, once my Uno turns on, once the power comes on, setup, whatever's in setup is going to run. Like, all the commands inside setup will run right away, but only one time. And only one time, and that's it, okay? Now, loop runs over and over again after setup runs. All right, so let's read that. It runs over and over again after setup runs. So let's think about it. Once the Uno wakes up, we give it power. It first runs all the commands inside setup. After it finishes setup, then it runs whatever's inside here. Right now there's nothing, but it runs whatever's inside here, and it runs it over and over again. All right, it never goes back to setup again. It will just go loop over and over again. All right, so now that we know that, I also want to mention that this guy, what are these? These are comments, okay? Comments are basically notes that you want to put in your code, but they're not commands that are run by the computer, okay? Because if the computer tries to run them, it's not going to understand. So the way that you tell the computer, like, hey, don't worry about this line, this is just a note for me, is you put these two slashes here, okay? And you'll notice it turns green once you do it. So I can compile, and what it did is it ignored line 2 and line 7 because I have these 2 slashes. If I don't have the slashes, check it out. See, it's black. It's going to get confused. Watch. Compile. See? It's like run does not name a type. It means, like, I don't know what runs is. So it's like, oh, I forgot my 2 slashes. To tell, okay, those are just notes for me. Don't worry about it, computer. All right? It's just for me. All right. Inside our loop, what I'm going to say is I want to say turn on the light. So I go digital right. Notice my lowercase d and capital W, parentheses 7, comma, high. Okay? Should we try this? Maybe we should try this. Okay, so let us compile. Cool. And then upload. All right, so once you do that, you have to select the device. This is basically telling the computer, because look, you're connecting this part, the USB cable, to your computer. You're telling the computer, like, where's this USB cable, right? Because your computer might have a few different USB connections, right? You're telling it to go to this Uno right here that's connected to this cable. Now, I'm on a Windows computer, so it's going to show up as USB 2.0 serial. If you're on a Mac or something, it might be something different. All right, but go ahead and click on the one. Usually there's just one, okay? And then you connect, and it's going to send it over. And what's going on? Did it turn on? It did not turn on. What is going on here? Well, you know what? Let's change it. Maybe I flipped it. Maybe it should be low. Right? Sometimes I'm just like, okay, maybe I flipped it. I got it wrong. If it doesn't work this way, let's try it the other way. Let's connect. There you go. Low turns it on. Interesting. So why is it like that? Why is it that when it's low, it turns on, right? And let's change it to high. It's off. Well, let's take a look at our circuit here. Okay, so look how we connected it. All right, I connected it this way, where 5V is connected to the resistor, connected to the light. So when I say low, what's going on is that it's making this connection all the way to G and D, but when I say high, it's not making the connection. So really it's the way that we connected it here. So there's other ways to connect it where it's not going to, you don't have to, where it's actually going to be flipped, where low is off and high is on. So for now I would just say let's connect it this way, all right? And we can actually flip it maybe next time and figure out how to connect it so that it works the other way. All right, so let's go back to here. All right, so sorry, going back to our code actually. Here we go. All right. So high is off, low is going to be on. Cool. All right. So now what I'm going to do is okay, so now our computer can control this. Let's do something more interesting. Check this out. I'm going to add, this is called a delay, okay, and I'll put a comment here. Delay is wait 1,000 milliseconds, which is the same as 1 second. So delay means it's going to first do this command, then I want to just chill out here, don't do anything, just chill out here for 1 second. And then I'm going to do 7 high, which if you remember for us, it's going to turn it off. And then delay 1,000 again, which you're going to wait another second. Okay, so check out the code, think about what it's going to do. It's going to, what I like to do is make comments. Turn LED on. Okay, that one turns it on. Then wait 1 second. Then turn LED off, because high is off. Okay. Let's see, I gotta refresh this here. And then wait 1 second here. All right, and then it's gonna turn wait 1 second here, and then what happens here, it runs over and over again after setup. So then it's going to go back to the very beginning, to line 11, and then go again, over and over again. So what's going to happen is it's going to go on for a second, off for a second, on for a second, off for a second. So it should blink. All right, so let's upload this. Check it out. It works. All right. So that's it for today. I'm going to give you guys some challenges here. All right. So challenges. Okay. The first one that we talked about was build 2 LED switch circuit. That was from earlier. Build 3 LED switch circuit. Make LED blink, which I just showed you how to do. Make LED blink fast. Okay. And then it's like, think about how do I do that? What do I need to change in order to make the light blink faster? And then make LED blink fast. Well, let me write it this way. Make 2 LEDs blink fast. So like, how would I do that? Make 3 LEDs blink fast. Okay, so a whole bunch there. So now we're gonna add more LEDs to this. All right, so that should keep you busy. Have fun with that. Talk to you guys later.